This video is gonna start about basics with algebraic expressions. It's not so much of a teaching video as it is a crash course. The idea is that you do understand laws of exponents, you understand the concept of like terms, the concept of adding, subtracting, multiplying, and dividing expressions, but you're not entirely confident with when and how to use them. If that is you, this video is for you. It's basically designed to teach you the difference of each case, how to identify what you need to do, and to realize what works and what doesn't work in specific situations, and make you a little bit more clued up on that entire concept. Even if you're just starting with algebraic expressions, or if you've been doing it for a while, uh, this might still help you just a little bit. So let's check it out. The concept is that there are four major operations in mathematics: plus, minus, times, and divide, and we need to know how they affect algebraic expressions. It's a problem that a lot of new students to algebra often have. It's just making silly mistakes. We're just trying to mitigate those through practice and pattern recognition. You get a addition, subtraction, multiplication, and division. Now, the first thing we need to understand is that when adding and subtracting, for these two columns, we need like terms. Very important. Number two, coefficients. The coefficients change. Number three, the variables and exponents stay the same. With multiplication and division, we don't need like terms. All right, so we don't need like terms. So when we're doing them, we're multiplying or dividing coefficients, whatever the case is. All right, so we're multiplying or dividing your coefficients, and with your variables and exponents, for your variables and exponents, we need to use laws of exponents. All right, let's begin with a couple of simple examples and see what's happening now. So for the first one, x plus x, we start by deciding, are these like terms? Is x and x identical? Do they have the same exponent? Yes, they do. Yes, they are like terms. So all we go ahead and do is we take the coefficients, which is a 1 and a 1, and you add them together to get 2x. X minus x. So I'm using the same two variables, x and x, and then we're going to use them for all the operations and see what the different answers look like. So in this case, like terms are needed again. The coefficients change and the variables and exponents stay the same. So 1x minus 1x. So we use 1 minus 1, which is 0, and coefficient and variable stays the same. So we got 0x. But we remember that 0 times x, because the coefficient and variables you always find the product of that, they're being multiplied. So 0x is just the same thing as 0, so it disappears. Then you get x times x. Now with this, we don't care about like terms. So they are like terms, it doesn't make a difference. We still do the same thing. We multiply the coefficients. So 1 times 1 is 1. Then for the variable and exponents, we apply laws of exponents. So x to the power 1 times x to the power 1. When multiplying the bases, you add the exponents. So you get 1x squared. With division, so you say x divided by x. Now, we don't care about like terms, so division, we divide our coefficients. 1 divided by 1 is 1. X to the power 1 divided by x to the power 1. So when you have that situation, you do a subtraction of your exponent. So 1 minus 1. So you get x to the power 0. And anything to the power 0 is just 1. So your final answer in this case is just 1. Essentially, your x's have cancelled off and they are gone. All right, let's do another example. So let me just rule off here. Let me also just rule off there. Mine's the untidiness. It's too late for that. Okay, so next question, let's do 2x plus 3x, or rather 5x plus 3x, 5x minus 3x, 5x times 3x, 5x divided by 3x. All right, now I would recommend you pause the video and try to write all 4 of those answers based on what we just did. Let's try. 5x plus 3x, we need like terms to add. The plus says we are adding, we need like terms. X and x are like, so we can add. The coefficients change. So 5 plus 3 is 8, and you're just left with x. The variable and exponent stays the same. 5x minus 3x, x's and x's are like terms. 5 minus 3 is 2, and x stays the same. 5x times 3x, so we don't care about like terms, they are, it doesn't make a difference. We multiply, so when you're multiplying, you say 5 times 3 is 15, and for your variable exponents, you apply laws of exponents. So x times x is going to be x squared. 5x divided by 3x, so you divide the coefficients. 5 divided by 3 as well, 5 over 3. X divided by x cancels, so you're just left with 5 over 3. All right, so let me know in the comments if you managed to get that first try right, because that's awesome. If you didn't, don't stress, you're going to eventually get them all right. So let's try this one here. 12x squared plus 5x. Okay, so make that 6x. 12x squared minus 6x. Then let's do 12x squared times 6x. Then let's do 12x squared divided by 6x. All right, so this is an exercise, as I mentioned, that teaches you the difference. It's a idea that's meant to train you not to make mistakes. So pause the video and make your mistakes now, so you don't have to make them in an exam. Now let's begin. 12x squared plus 6x, these are not like terms, you cannot add them, so it just comes down to the next line exactly without changing. All right, we don't say there's no answer. They still exist, they just can't be simplified, but they are still as they are, so we accept them for who they are without changing them. All right, so 12x squared minus 6x. Again, to subtract, you need like terms. If there's no like terms, you can't subtract. Bring it down. Then we've got 12x squared times 6x. Now 12 times 6 is going to be 72. X squared times x is going to be x to the power 3. 12 divided by 6 is going to be 2, and x squared divided by x is going to be x to the 1. You're subtracting those exponents. All right. Let me know in the comments if you got the first batch wrong but got the second batch right. So you're just showing me whether you're improving or not. Let's try this one. 20x squared. Let's make x to the power 4 plus 8x to the power 3. All right, 20x to the power 4 minus 8x to the power 3. 20x to the power 4 times 8 x to the power 3. um I don't know why I chose 8, but anyway, let's actually just change that to 4. So 20 x to the power 4 divided by 4x to the power 3. Alright, it doesn't make that much of a difference, but we can make all of these 4 or not, it's fine. Pause it and try your video, try your answers. So 20x to the power 4 plus 8x to the power 3, that can't change. They can't be added, so just write them down. Then 20x to the power 4 minus 8x to the power 3 can't change, bring it down. 20x to the power 4 times 8x to the power 3, 20 times 8 is 160. X to the power 4 times x to the power 3 is x to the power 7. And then you got 20 divided by 4, which is 5, x to the power 1. All right. Initially, I was planning to do a few more, but I feel like this should have given you that upper hand you need for these questions. It should have given you an idea. If you're still having a problem, let me know in the comments what your questions are. Is there a question I haven't answered? Is there something that still does not make sense? Or maybe I can revisit this and try to answer any outstanding questions. If this did help, subscribe, like, and